The timer is gonna go for 1 hour and 30 minutes or 1 hour and 28 minutes now. I'm trying to tackle a challenge called ICA, Industry Coding Assessment, prepared by CodeSignal. I have already solved a bunch of challenges, as you can see here, but I'm gonna simulate new coding challenge. I'm gonna write down the prompt in a while, but that's the goal today. Ask Google to simulate the challenge, completely new challenge, and solve it in this Google Doc, and then get back to it and again solve next level. So a little about ICA challenge. ICA challenge is prepared by CodeSignal. It has 4 levels. You can't go to level 2, level 3, or level 4 before you solve level 1. And so on, only one level at a time, and it progresses as we go. And the difficulty level grows as new levels open. However, for level 2, you're modifying the code from level 1. So it's one big problem in multiple levels. So I'm gonna write a prompt saying, let's solve another challenge. Completely I think this will work. I don't know if it remembers the context, otherwise I will create a new thread. Okay. Alright, this time I got the challenge about text search engine. So in level 1, I have to, let's not look at the hint, I have to implement 3 different methods in a class. So let's get right to it. So the class is gonna be text search engine. So class. And forgive me about this weird uppercase, lowercase stuff. I think I can bump up the text size so that you guys can see better, but I'm gonna write text search engine class, and underneath that I'm gonna have to initialize this class with the init method, and I'll need self for sure, right? And it's gonna be the class to handle documents looks like, and I have document ID and content, which are both string. So what I can do is I can have a simple Assesment to store the documents. With doing bunch of challenges before this, I have understood that Assesment is usually the better data structure to use because of its fast query O1. So what I will say is self the documents equals a hash map, and this hash map is going to be formatted like so. So for example, sorry, that was a beeper. doc1, and we'll have the content one, right? Like just like that. That's one item in the hash map, and we may modify this as our requirement, but I don't think we need to modify that right now. And then we'll define add document method. So let me copy this just real quick. Add document ID is gonna be string, content is gonna be string, and this is gonna return boolean. When are we returning false? If document with this document ID already exists, so if doc ID in self.documents, we're gonna return false, right? Meaning we did not add anything. If that is not the case, then we will register a document with unique doc ID and parses its content. The content string consists of 2 words separated by single space. Oh, ooh. What are those? What could those be? Return true if the document was successfully added and indexed. Now, what does that indexed means? Register the document with unique document ID and parses its content. The content string consists of 2 words separated by single space. Okay, there are multiple words, so I don't think that can be one big content. So what I'm going to do is self.documents of doc ID is going to be content, right? I just add the content and then return true, right? Yep. Then I'm gonna create a new method that's gonna be get content with doc ID, which will return a string, probably return the content or none. Okay. What is it saying? Return none if the doc ID does not exist in the engine. Okay. If doc ID not in self.document, return none. Else return the raw content string associated with the doc ID. So return self.documents of doc ID, right? Okay, then delete document. So def delete document, and this is going to return a boolean. Get a self here. Also here. Also here. Okay. What is delete document going to do? If the delete document does not exist, it's going to return false. So same thing is here. If it does not exist, then we're just gonna return false. And permanently purge the document with the indexes, with its indexes entries. System return true after. What is the index thing? It's my the level 2. Okay, we're just gonna delete that from the del self.documents with doc ID, right? Yeah, 3 methods. It's talking about content.split to tokenize words efficiently. So if we wanna search later, should I store this as a list by splitting it? Okay, we will see. This is the hint. I should have actually said don't give me any hints, but okay, I think this is good for now. So let's copy this code and paste here. Your level 1 storage skeleton is perfectly clean and utilizes port 1 lookup. Now, I'm not looking at the hint anymore. Now, search word, okay? def search word. There is gonna be word and there is gonna be limit. And this is returning the list of strings. So what is it about? Find up to limit document IDs that contain the exact case sensitive string, word, sorting priority 1, sort the document by IDs, sort document IDs by the frequency count of how many times the word occurs in the document in descending order. Priority 2, tiebreaker. If two matching documents contain the same exact number of words, then alphabetically by doc ID in the ascending order. Okay. If no documents in the word, return an empty list. Okay, easy. Okay, so for this, what we gotta do is I'm gonna initiate a result as results variable, which is gonna be a list, and in this I'm gonna store doc ID doc ID, yeah, doc ID for doc ID self documents if if self dot documents of doc ID, if in that document body, this is gonna give me the document body or the content, I'm gonna split that, right? And that will split with this space, I believe, right? Yeah, and then dot count, and I'm gonna get the count of word, and it says case sensitive, so I think count is case sensitive. Now this is the frequency, right? If this is greater than 0, meaning there is some frequency, right? Does it want finds up to limit document that contain exact case sensitive string word. Yeah, that does the search. And I also actually wanna build a tuple of this frequency. Right, doc ID, the frequency for doc ID himself, the documents. If document self documents, if that frequency is greater than 0. Okay, now what I gotta do is I gotta sort this results. Dot sort. This will sort in place, and I'm gonna use the key equals lambda function, and lambda, and I'm gonna pass x as a parameter. So first thing we're gonna do frequency but in descending order. So I'm gonna do minus x of this. This is the second item is the frequency. So x of 1. I'm gonna use a tuple as a sorting parameter, and then the second one is gonna be the doc ID, which is in the the first parameter, so x is 0, but this one is ascending, right? And I'm gonna close that couple right here, and then this will sort it. Now what I'm gonna do is I'm gonna just return up to limit, so less than that. So what I'm gonna do is return. Now I'm returning just the doc IDs, right? Limit kind of limit. What does it want me to return? List of strings, so it's probably the doc IDs. So what I'm gonna do is x of 0, because it's in the 0 item, right? For x in results, then I'm gonna slice this up to limit. So you start from the beginning and go up to the limit. It's already sorted, so I think this will do it. And if there is no result, I mean there's no match, if the frequency is 0 for all, then the result will be an empty list. So empty list will still be returned. Yeah, I think this is good. Split or count they're talking about, so let me just paste this. Okay, here. The solution shows that you have perfect graphs of Python multi-key sorting. To pull this and performance bottleneck analysis in search where you're calling split and count multiple times. Yeah, this might cause. Yeah, I might actually break this into full loop, full for loop, and then do the construction. The TLE time limit exceeded trap. Yeah, and if I have to do some optimization, I'm definitely extending this to full for loop rather than doing list comprehension. But I think we're good now. What's in level 3? I'm not gonna look the hint. 2 methods: add document, search for advanced. So what is in the add document? This is updated. Saves the raw text, tokenizes it by space, maps the word frequency directly into the lookup index for future searches. Not sure if I understood this. Saves the raw text, tokenizes it by space. Maps word frequency directly into the lookup index for future. Does it mean I need to have frequency sub dictionary? So this could be this, right? What I could do is I could add this as a substring or sub dictionary, and within sub dictionary I'm going to say content equal content 1, right? And then frequency map the word by frequency. I think what I'm gonna do is, I think that would be very deep nesting. So FRPP, I could do this. And in this dictionary, I can have like word and the count of the word. But then that's level 1, level 2, level 3. I don't like that. I don't like more than one level or more than 2 levels. What I'm gonna do is I'm gonna undo this. Right now it's gonna be like that, and I'm gonna say self dot frequency equals to this, and this is gonna have list or dictionary where it will have of course a doc ID, right? Say doc 1, and this will have a sub dictionary where it has like a word 1, and then the count of word 1, say 2, word 2, count of word 2, maybe 3, right? Like that. And then for every document I have the indexes or the frequencies, right? I think that's what I'm gonna do. That's what I'm thinking. But how are people thinking? Anybody here? Secret Pandey came by and he left by, I think. The background song overlaps our voice. Dai alta sound ground so that we can hear you better. Is that one person you? Damn. Well, that makes me happy. Let me make it super small. How is that? Dude, what are you doing here, bro? How much time do I have remaining? Okay, not even half an hour, so I'm good. I'm already in level 3. I can talk to you for a while. Nice trick. What is the trick? Lovely. How is life, bye? Sounds it so? Oh no, my time review is about to be over. Yes, guy, pretty fine. Good, man. Good. How is your application going? You mean job application? Pretty good. It's going. I have an assessment happening tomorrow. That is actually why I'm working on this yesterday. It's the Ek Tir Do Nisani. But anyway, how about we keep going? Let's keep going, yeah? Okay, so I decided about having second attribute in my class, frequencies. So I need to modify my add document. So when I have the doc ID and documents, I'm definitely gonna have doc ID in my frequencies. So what I'm gonna do is frequencies or for yeah. So yeah, so what I'm gonna do is I'm also gonna do self dot documents of doc ID, not documents actually, frequencies of doc ID equals an empty dictionary, and I'm gonna say for word in content dot split. So content, split that by space, and then for each word I'm gonna say self dot frequency of doc ID of that word is gonna be either whatever number doc ID dot get, whatever the value of that word is, and then if that does not exist yet, we're going to initiate with 0, right, plus 1, right, because we just encountered one of that word, and what we're going to do that is we're going to increase that by 1, but if that never existed before, then we're going to say self.frequencies doc ID dot get word if it exists, whatever it is, and if it does not exist, this get function just returns 0. So we're going to say 0 plus 1, which is the first one word, right? And then by the end of this loop, we should have our frequency dictionary 2, right? And then we'll return true. And then in the search word advanced, right, this is just search word. I think we should just keep search word too, right? But then let's define a new method called search word advanced. So put self in here, and this is gonna be case sensitive. Oh, now they're gonna tell me whether it is case sensitive or not. Wow, okay. Alright. They're gonna give me word, they're gonna give me limit, and they're gonna tell me whether it is case sensitive or not. So there will be two directions whether or not we're dealing with case sensitive or not. Get this in one line. So how are we gonna start? We're gonna get the doc ID. We're gonna use our frequencies this time. All right. So we're gonna build our result two ways. If case sensitive, if it is case sensitive, then we're gonna say a results equals list of doc ID. All right, seeker, for doc ID in self. Oops, where did I go? In self dot. Come on. Frequencies. F-R-E-Q-E-N-C-I-E is frequencies. If if it is case sensitive, then it will be as it is. So if word in self dot frequencies of that document. All right, and we're not just getting the doc ID, but also the frequency of that word. So the frequency of that word is gonna be self.doc ID and the frequency of that word. All right. Yep. Now if else if the thing is not case sensitive, then what we can do is we can just say this is, we can just say, we can just put lower lower word, and then doc ID in self frequency if lower word. I'm just lowercasing all the words and the actual frequency as well. Lower word in doc dot frequency. Now how do I actually I think I need to use regex here. I need to see if every character, because you see the problem here, I can lower the word, but I can't lower the keys in the frequencies doc ID. Or can I? Nope. Let's do a Google search. How to check if two the words are equal, not case sensitive. Python. Oh, there's case fold, but I want to see if it exists. I have list of dictionary of with key as WR. I wanna check if any word is the key, not case sensitive. Yeah, they unwrapped the keys. I don't think there is any other way. Yeah. The problem is I need to use it here too, the lower word, but then because I need the frequency too, right? That means I need to know whatever that existing word is the key is. So let's simplify. Let's simplify this whole thing. Ooh, I wasted a lot of time. How much time I got? 15 minutes. Okay. So what are we gonna do? Let's loop for doc ID in self.frequency frequency. Right, for doc ID in self.frequencies. Now what I'm going to do here is I'm going to initialize result as an empty list over here. If doc ID in self.frequencies or I'm gonna make for each document I'm gonna make the list of tuples of its key and the frequency value. So what I'm gonna do is free FREQ frex equals k tuple of key comma v for key comma v are in self.frequencies. Frequencies of doc ID items. Right, this way I have the tuple of list of tuples with key and values, right? And what I'm gonna do is, if case sensitive, and I'm gonna have to check the first item. Yeah, what I'm gonna do is I'm gonna loop through each of these key values for. It's a lot of loop, not definitely very efficient, but let's go that way. For K, comma V in REQs, if case sensitive, and lower. If it is case sensitive, then we are just gonna say key equals word, right? Then we're gonna immediately append this doc ID in the results. So results dot and the tuple of K comma V, right? The frequency and that key. Now else, if K is not equals to word, and it is not case sensitive, then if it is not case sensitive, then we can lower both. So else or LF not case sensitive, what I'm gonna do is and lower case equals to lower of word, then I am going to append, right? Either way I'm gonna append, so this or this. So I can just get rid of that. Okay, so in two conditions I'm appending to the result. If K equals word and case sensitive, meaning it is exactly equal, or not case sensitive search and lower of K equals lower of word, then also I append to the result. And by the end, after we loop through each keys, if the search match never happens, then this document ID will never be appended to our result. I think I'm not appending the key. The key is the document ID. So this is key is the word. So I'm gonna have to append the doc ID, and as soon as the match is found, we can just break the loop, because this is a valid result. So we'll say break. All right, break this loop, and then we go to the next document ID. Cool. Okay. And then I think the sorting just happens like before, right? Because I have the document ID and the word and the value, which is the frequency here. So we'll sort by the frequency first, and then the name, and then we will return up to the result or up to the limit. I think that's pretty cool. Let's give it to the Google AI and then see what it says. Okay, it says your pre-computed self-read frequency structure mapping doc ID and count is a step in the right direction. It properly saved the intensive tokenization process split. However, your implementation contains major logical inversion box. What is that? Invert case sensitive logic. If case is case sensitive and k equals where, look closely to your list. Did I do it oppositely? And not case sensitive and lower of both are equal. The bug. If case sensitive is true, you should perform a lower matching comparison. Instead, if instead you evaluated case sensitive exact is k equals where on case sensitive branch. Python string do not have top level. Did I do dot lowers here? Okay, dot lower. But that doesn't make any sense to me. If case sensitive and k dot lower equals to word dot lower, results dot append doc ID. This has to be the parentheses as well. But how? If it is case sensitive, then it has to be exactly equal, right? And if it is not case sensitive, then its lowers can be equal, because okay, the bug, the documents contains tokens apple and apple. Your loop appends the frequency of the first variant, happens hit, and then stops. Yes, because the lower quite does not work. In your source were advanced, you wrote for frequencies and missing. That I neglected. So how did they implement it? Doc ID, word map. What is the word? Okay, self-read frequency dot items. Total frequency equals to 0. If case sensitive, total lower, target lower is to word lower. If KV, Total frequency plus equals 1, because there could be frequency for 3 different, or like however many different kind of. Okay. But they are doing just case sensitive, meaning it has to be exactly the same, right? Accumulate the sum of all variants of breaking early. So case sensitive meaning all variant, and if it is not case sensitive, looks up the exact string. If total frequency equal greater than 0, then we're gonna append that. I understand that, but I still think they are doing just the opposite. I mean, AI can't be wrong, but so case sensitive means all 3 are valid. Okay. What's the time? Still 37 minutes, bro. I'm way ahead in time. 3 people are here. Wow. Okay. Seeker, and who's the Bruce here? Nice, my friend. Thanks, man. More back to a couple of minutes, Madai. Okie dokie. Are you still here? Yeah, I got my brain bent slightly because I just thought case sensitive is reverse of what this problem is thinking. I thought case sensitive meaning it has to be strictly match, but it looks like it is otherwise. Case sensitive means there can be the match of any like cases, lowercase, uppercase, or whatever, because they are checking the lower of it, right? Yeah. Okay. So what I'm gonna do is I'm going to copy this and do a little bit of cheating over here. Actually, from here. That is why not always the list comprehension will help. Have to break down into the loop. Oops, what was that? Okay, so for doc ID world map this, and then create total frequency, and if it is case sensitive, then I think we're doing all that this way, and then if it is not case sensitive, then we are doing direct. So maybe I understood it wrong. Case sensitive search means be sensitive to cases and look for all possible matches. I think that's what it means, and otherwise it has to be strict. I think that is what it means, but it just doesn't really make sense to me. And then this is still valid. So now AI basically implemented the advanced search. Let's see what is the 4th challenge is. So it wants me to implement one more method that's called get search snippet. Damn, looks hard. Okay, we'll see. Self, and it is either returning a string or non. What is it I'm talking about? Let's see. Generates a contextual text snippet from doc ID centered around the first occurrence of exact case sensitive match of the word. snippet definition. The snippet is built by taking the target word, extracting up to radius words immediately before it, and up to the radius word immediately after it. Wow, that's interesting. So this is exact case sensitive match. So now, are they talking about the exact match? Because this does not make any sense to me. What do you guys think? Yeah, so they are saying case sensitive, and then if it is case sensitive, they are trying to get all possible occurrences of the word. And now here they are saying there will be one word, because this is going to be case sensitive search. And then what it wants me to do is, this is actually pretty simple, pretty easy, I think, but it's just the search that I'm not understanding. What it wants me to do is whichever index, right, whichever index I find that word, get radius, and radius is an integer, get radius many words before that word, and radius many words after that word, right? Now that should not be very difficult. I think I can use my advanced word search for that, and then I can just index. But what is it saying? So returns none if the doc ID doesn't exist, or exact case sensitive word is not present. Okay, returns the compiled snippet of the string. And then formatting constants. The extracted tokens must be combined back into the single string separated by the single spaces. The target words occurs near the beginning and end of the document. Simply extract as many words as they're available within the radius. Okay. Pretty simple. So what I'm gonna do first is, if doc ID not in self dot frequency, if doc ID does not exist any already, right? If doc ID not in self dot documents or frequencies, I get to either ways because it exists in both. If it exists, FREQUENCI frequencies. If it is not in that, or not, right, if the result is not, if the word does not exist, so what I'm going to do is I'm going to search, so self dot search advanced words, and what I'm going to do is I'm going to provide this word, and I'm going to provide limit. Now limit, how many, limit basically means how many documents, right? Oh, is there any document ID? Sorry. Oh, it also gives me the doc ID. So I have to search in a specific document. So let's handle one thing at a time. How about that? So we're gonna do If document ID is not in self.frequencies, we're going to say self return. What are we returning if it does not exist? None. Right, and also now we're going to find in that document we're going to find the exact case sensitive match. So what I'm gonna do is, we already have doc ID, so word map equals self.frequency of that document doc ID, right? And then what are we gonna do? We're gonna do this thing. So we're gonna say total frequency equals 0. Yeah, so case sensitive is this, but I think we're gonna have to be there could be multiple of that words, right? Anyway, so what does this mean? The snippet is built by taking the target word, extracting up to radius words before it and up to radius word immediately after it. Generate a contextual text snippet from doc ID centered around the first occurrence. First occurrence of exact case sensitive match of the word. Why am I doing all this stuff? Okay, and if the exact case sensitive word is not present in the document, then also return none. So I can I'm making things hard. And word not in self.documents of that doc ID. If doc ID is not in, I can say documents. If it is not in the documents and then the word is not in the self.documents in that content, then I return none, right? And if it exists, then I know it is there, so I'm gonna find the first occurrence of that word. So what I'm gonna do is idx equals self dot, so let me get that content and then let me split that, and then this will give me a list, right? This will be a list. I'm gonna find the index of this word in that list, right? So this will return me the index of the first, right, of the first of the first occurrence of that word. And what I'm gonna do is, let's actually do cont as list equals split that, right? and then what I'm going to do is copy that and find the index, and then I'm going to return, actually let's first build result, result result equals, we're gonna start from, we're gonna slice this cont as list, right, content as list, and our starting thing is gonna be either 0, so whichever is the max, right, max of 0, or the idx minus radius, so radius is given here, right? So either come all the way up to 0 or come up to the idx minus radius, and then the ending one will be whichever is the minimum of the len of cont as list minus 1, or the idx plus radius. Do you understand this, guys? I think it makes sense. So I'm trying to get the radius many words from the beginning, and less if there is less word, and then radius many words from the later part, right part, and if there are less, then we'll just go up to all the way up to the end of the list, right? Oh, this can't be minus 1 because this goes up to but not including, right? So I think, but this one has to be plus 1 because it goes idx plus radius but up to that but not including that. So yeah, there it is. Now what I'm gonna do is return I'm gonna join this by space. I think I'm gonna have to join that by space dot join, and I'm gonna join the result items in the result. That's it. I think we got it. Let's see what this guy is gonna think. Oh, indentation is not working, but I think that's fine. Your implementation for level 4 is exceptionally clean. You nailed slicing window perfectly using max and min and the join. However, your validation guard contains a logical flaw and a crash hazard that would trigger immediately key error, where if doc id not in self dot documents and word not in self dot documents of doc id return none. Oh, this will yeah, in because there is and this will still check. So what I'm gonna have to do is just this. If this, then still return none. See, that will fix it, because it will check only if the document is in self.documents, then this. Yeah. Is that what it is saying? Yep, there it is. Then yeah, idx nice, we did it. And what's the time remaining? 19 minutes. Well, also, like, I kind of did not fully solve the advanced search because of the case sensitive thing, but I got it done like 20 minutes in advance. That's pretty cool. Still 3 people watching. That is insane. I cannot believe you guys. What are you guys doing here? Did it. Let's go level. Oh my god, Seeker. Alright, man. You are just an awesome man. Let's talk. It's time to talk.